this video, we're going to practice calculating limits. So let's try an example here. Let's find the limit as x goes to -4 of x squared minus 16 over x squared minus 5x minus 36. So there's our problem. Now, before we launch into the calculation, let's make sure that we understand the question. We're going to make a little chart here of x values, and these x values should be near -4, and they should be getting closer to -4. So for example, we could start at -5 and then move to -4.5 and then maybe to -4.1. So close to -4, and as we move to the right, we're getting closer and closer to -4. Now for each of these x values, let's take them and plug them into this function here. Okay, so I've calculated these values in advance. Let's say we want to just round them off to 2 decimal places. Okay, and you may want to just pause the video here, try using your calculator to calculate these values, and then you can just compare your answers. So when we plug -5 into this function here, we get approximately 0.64. Plugging in -4.5, we get 0.63. And plugging in -4.1, we get 0.62. Okay, we also may want to try this with some x values that are a little bit bigger than -4. So for example, we could try it with -3.8 and -3.9. So that way, again, we've got some x values that are close to -4, and they are getting closer to -4 as we move across to the right. So same idea. If we call this function here, let's call it f of x. So we don't need to rewrite it all over again here. We're going to find values of f of x at these particular x values. So again, you can check this on your calculator. When we plug in -3.8, we get 0.61 approximately, and -3.9 also gives us a value of 0.61. All right, so when we ask for the value of a limit, what we are doing is we're looking at these x values that are approaching -4, and we're imagining getting closer and closer to the x value -4, and we're trying to predict what our function is going to look like as the x values get closer and closer to -4. So we're trying to predict what this question mark value is. And similarly down here, as we approach -4 now from the other direction, we're trying to figure out what f of x looks like. So if these two values here happen to be the same, then we say this value is the limit as x goes to -4 of, of our function. Okay, so we're trying to find these question mark values here. Now, a bit of a technicality, if the question mark values are different in the two charts, then the limit is said to not exist. So in this example here, we might guess that the limit has a value of about maybe 0.61 or 0.62 based on our charts here. So now we're ready to actually start the problem. And let's start with our calculation. So if we saw this problem here on a test, first thing we would probably do is plug in x equal -4 and just figure out what value we're getting in our function here. We'd have 0 on top, so 0 in the numerator. We'd also have 0 in the denominator. So we have this 0 over 0 or undefined value. So the fact that we have 0 over 0 is what suggests that we have to do some factoring to solve the problem. So here's where limit as x goes to -4 of our function is equal to the limit as x goes to -4. And now we're going to need to factor the numerator and the denominator. Well, on top we've got a difference of squares. So this will factor as x minus 4 times x plus 4. And in the denominator, to factor the denominator, we're looking for a couple of numbers that multiply to -36 and add to -5. So -9 and plus 4 would work. We could write x minus 9 times x plus 4. Now, if we try plugging in x equal -4 at this point, we've still got 0 over 0. But you might notice that we can cancel now a factor of x plus 4 from the numerator and the denominator. Now, the reason we're able to do this is because a limit is about what is happening near x equal -4. So imagine that x is very close to -4, but not quite equal to -4. That means that these values here, the x plus 4 value, is very close to 0, but it's not quite 0, and that's what's allowing us to do this cancellation here. Well, now we're left with just a nice looking function. We've got x minus 4 on top, x minus 9 in the denominator, and this is the very first step where it makes sense to plug in x equal -4. So if we go ahead and plug in, we no longer need our limit expression because we're substituting x equal -4 into this expression, and we'll end up with -8 over -13, or in other words, 8 over 13. And this is the answer to the question. So we could write limit as x goes to -4 of x squared minus 16 over x squared minus 5x minus 36 is equal to 8 over 13. And if we wanted to compare this to our guess from before, you can check using your calculator. 8 over 13 gives a value of about 0.62. So just to recap, we use this chart method here just to understand what exactly a limit is, to give us a rough guess for what the answer would be, but the actual calculation happens over on this side. So if you were to see this question, say on a test, you would start with just plugging in your x value. If you get 0 over 0, that suggests that there's some factoring to be done.